Okay, so for this problem, you're playing a game against your friend, and there's this nut in the wall, and the goal is both of you have a wrench, and you're trying to twist it, and whoever gets to twist the wrench in the direction that they're pushing wins the game. So the goal is going to be to figure out how much force we need to exert on our wrench to at least equal the amount of torque that your friend is exerting or causing on the nut. And so based on that, we know that torque is equal to just a force multiplied by the distance that it's being, that's being acted upon based on how far it is from the axis of rotation. So we'll just call that R. So for this, we're just going to break down the left and right side of this game. And based on that, we'll be able to figure out how much force you need to exert to at least equal the amount of torque that your friend is causing. So if we do sum of torques on the left side, I'll just put that L to denote the left side. That must be equal to the sum of torques on the right side. And this is, as I said earlier, because to win the game, we need to at least match the amount of torque that is being caused by the other party. So from here we can use the first equation and plug in for each of these two variables. So on the left side we just have your friend's wrench, and we'll notice that the force we're given is 12 newtons, so we can just say 12 newtons multiplied by a radius of 1/2 meters. Okay, and that's everything over here, right? So these forces are acting in this direction, right? And those are the only forces acting to rotate it this way. And your forces, your team in a sense, are trying to rotate it this way. So this is all that's going for this direction. Now we're going to flip directions. For your wrench, you have a different wrench that's 1 meter long, so you actually have twice the amount of leverage, as they say. So in this case, the force is something that we don't know. And that's going to be something that we need to pay attention to, because right here, if you'll notice, this is a little arrow representing your force. So the force that you're exerting isn't exactly perpendicular like your friend's is. So we need to actually figure out what component of this force is actually contributing to the rotation. Because if we break this down into two components, we'll just call this F. We have two components here. So we have what we'll call Fx and what we'll call Fy. And in this case, Fy is going to be the only one contributing to the rotation. Because if you think about it, you have a wrench hooked up to a nut. All this Fx is you're pulling along the wrench, right? All that does is, it's nothing. It's just pulling against the nut. It's not going to cause it to rotate. So what we're really looking for is this Fy as a part of this torque. And Fy we know just from trigonometry. If this angle is 30 degrees, we can say that Fy is equal to F sine 30. And so now we're going to use this relationship and plug into here. So first we're going to use the force, which is Fy, remember, because that's the component that's contributing to rotation. So F sine 30 degrees. And now we multiply that by a radius, which is 1 meter. Okay, so from here, it's pretty simple. We can cross out the 1 and the meters over here. Solve for the left side, we have 6 newtons, which is equal to F times sine 30, which you can plug into your calculator if you don't know, but it's 1/2. Okay, and then we just solve for F and we get 12 newtons. So you'll see that even though your wrench is twice as long, it's because this angle over here that both of the forces that you're exerting are actually going to be the same, because the increase in leverage, per se, by the wrench cancels out with the decrease in leverage caused by the angle that you have to push at.